We've been watching the large language model world kind of split into two very distinct lanes over the last year or so.
That's a good way to put it.
On one side, you have the open source community, and they're making this, incredible steady progress.
For sure. But then you look over at the other lane, the proprietary systems, OpenAI, DeepMind, Anthropic.
And their trajectory is just accelerating at a rate that's, well, it's creating what some are calling a great divergence.
It really is. That performance gap, especially when you get into these really complex reasoning tasks, it's widening a lot.
And that's what's so fascinating here, because the open community isn't just, accepting it.
No, not at all. They've gone into this deep self-analysis and they've pinpointed exactly why they're falling behind.
And it boiled down to three things, right?
Yeah, three structural vulnerabilities. First, architectural inefficiency. Second, not enough computational investment in that crucial post-training phase.
And the third?
A lag in how well their AI agents can generalize and, follow complex multi-step instructions.
And that strategic diagnosis brings us to our mission today, DeepSeek-V3.2.
Right. An effort by DeepSeek AI that is, it's probably the most forceful and calculated attempt yet to close that very gap.
They set out specifically to dismantle those three limitations, and frankly, the results are pretty staggering.
Oh, absolutely. The ultimate proof is it's breathtaking. Their high compute experimental version, they call it DeepSeek-V3.2 Special.
The special model.
That's the one. It achieved reasoning proficiency on par with leading closed-source systems, specifically matching Gemini 3.0 Pro on some key metrics.
But the big headline, the thing that made everyone sit up,
is that it secured gold medal level performance in the 2025 International Mathematical Olympiad, the IMO, and the International Olympiad in Informatics.
That's not just suggesting compute can buy world-class reasoning.
It proves it. It's a tectonic shift in what we thought was possible for open source.
Okay, so let's dive deep into how they pulled this off. This trifecta of wins efficiency, stability, and generalization. And it all starts right at the foundation with the architecture.
Absolutely. If you're going to pour massive compute into a model, you first have to make sure the system can even handle it efficiently.
And the bottleneck was the industry's reliance on, vanilla attention.
The very same. The standard mechanism from that original 2017 Transformer paper, DeepSeek AI, recognized that was the primary limiter.
So explain that for us.
Yeah.
Why is that standard attention mechanism such a huge problem, especially now that context windows are getting, huge, 128K, a million tokens?
Well, think about it like traffic. In traditional attention, when the model processes a very long sequence, every single token has to pay attention to every single other token.
Every car checking in with every other car on the highway.
Exactly. So if your sequence length is L, the computational cost grows quadratically. O of L squared.
So we double the document length, the work quadruples.
It's an explosion of cost. And it makes long context analysis just cripplingly expensive to deploy.
A system that just grinds to a halt. So the solution they engineered, this DeepSeek Sparse Attention, or DSA, that's the fix.
Precisely. DSA is all about reducing that complexity from O of L squared down to O of L times K.
And K is the key here.
It is.
Yeah.
K is the very small number of tokens the model actually selects to pay attention to. It stops looking at every car and uses a smart nav system to only look at the most relevant ones nearby.
Okay, so how does it decide which ones are the relevant ones? How does it avoid skipping over that one crucial detail buried deep in the text?
It's a really clever two-stage process. First, there's a component they call a lightning indexer.
A lightning indexer.
Yeah, it's a lightweight thing that quickly calculates a rough score between the query and all the other tokens. It's like a fast scout, just identifying the general location of relevant info.
Finding the hotspots.
Exactly. Then the second component kicks in, the fine-grained token selection mechanism. It uses those scores from the Skype to retrieve only the actual data, the key value entries for the top K-scoring tokens.
So it's like selective reading, but at a massive scale.
That's a perfect way to describe it.
Now that sounds like a huge efficiency gain. But usually when you do something like that, you simplify things, you compromise on accuracy. Did they check the quality?
They did. They ran a detailed parity evaluation and showed that DeepSeek V3.2 with DSA had no substantial performance drop compared to its predecessor.
So no degradation.
In fact, on some long context benchmarks, it actually did slightly better. They proved you could get the efficiency without sacrificing the performance.
And here's where, the listener should really lean in. The economic impact. Looking at their paper, at figure 3, the cost difference is just transformative.
Absolutely. The graph shows the old model's costs just spiking as the context length gets longer. DSA flattens that curve
So
dramatically.
at 128K tokens, the cost per million tokens is...
Substantially lower. And for the open source community, this is massive. It's the difference between a cool research paper and a system you can actually afford to run.
Okay, so that architectural win sets the stage. Now let's move to that second limitation they identified. Skimping on post-training compute.
Right. Historically, open models put almost all their budget into that initial pre-training phase.
And that was holding them back on the really hard stuff.
It was the reason they couldn't compete on high-level reasoning or complex instruction following. So DeepSeek AI just changed the equation. They allocated a post-training budget of over 10% of the entire pre-training cost.
Wait, say that again. 10% of the entire pre-training budget just for the refinement stage?
Unprecedented in the open community. It's a huge investment.
So what did that massive budget actually buy them?
It bought them stability and it bought them specialization. The pipeline started with something called specialist distillation. They created 6 dedicated expert models.
For different domains.
Exactly. Math, programming, general reasoning, and then 3 different kinds of agentic tasks. Then they distilled all of that expertise into the final model.
And crucially, they didn't train these one after another, which can cause that catastrophic forgetting problem.
No, they used a mixed RL training approach with group relative policy optimization, GRPO, that let them merge reasoning, agent skills, and human alignment all into one single robust training stage.
Okay, but if you're running an RL pipeline that massive, stability has to be your #1 concern. How did they keep it from just flying apart?
They focused on 3 really key strategies. First, they fixed the math. They used something called an unbiased KL estimate.
KL divergence. That's the penalty that keeps the new model from straying too far from the old one, right?
That's it. And they realized the standard way of estimating it had systematic errors that were destabilizing the training. So they corrected the estimator, which made convergence much smoother.
They made sure their risk assessment was mathematically sound.
Precisely. And they even found that for pure reasoning domains like math, they could get away with a weaker penalty, or even none at all, which let the model learn more aggressively.
What about the data itself? RL is famous for generating a lot of junk, a lot of mistakes.
And that was the second strategy, off-policy sequence masking. The model generates these negative sequences that are just noisy and unhelpful.
And if you train on those,
You're learning from bad examples, and it destabilizes everything. So they introduced a binary mask that just cuts out those noisy sequences. It lets the model focus only on learning from the good stuff.
that's smart, like a really aggressive editor.
Yeah.
And what about the mixture of experts part of the architecture?
For MOE stability, they use 2 techniques. Keep reading and keep sampling mask. Keep reading basically just makes sure the same expert pathways are used consistently for the same kinds of data.
So no sudden shifts in who handles what task.
Right. And keep sampling mask just ensures that the new policy and the old policy are operating within the same defined language space during generation. It's all about consistency.
So that's the whole stabilization recipe. Fix the architecture, stabilize the training, and now you have the confidence to pour in that huge compute budget. Which brings us to limitation number 3, agent generalization.
Correct. Moving from a chatbot to a functional partner. And the key bottleneck here was data. Real-world agent data is messy. It's hard to verify.
So their solution was, what, strategic brute force?
You could call it that. Larger-scale agentic task synthesis. They built a pipeline that generated over 1,800 distinct environments and 85,000 complex, verifiable prompts.
And these weren't just simple tasks. They built entire sandboxes from scratch.
Yes, for things like code or search, they could use real-world APIs. But for the general agent category, the environments were all synthetically constructed. The goal was maximum difficulty, but with easy verifiability.
And the trip planning task from the paper is a perfect example of this. Just how complex did they make it?
Oh, it's a great stress test. The agent has to plan a 3-day trip, searching a massive combinatorial space with all these nested constraints.
For instance,
The hotel price you pick for day 1 might dictate the restaurant rating you can afford on day 2, which then limits the cost of attractions on day 3. One wrong tool call, one ignored constraint, and the whole plan just fails.
and the crucial part is showing that training in these synthetic worlds actually translates to real-world performance.
And the ablation study proved it did. They showed that large-scale RL training on this synthetic data led to substantial improvements on completely out-of-domain benchmarks like 2-bench and MCP universe.
So it learned a general skill, not just how to solve the trip planning puzzle.
It learned how to reason and compose tools, which is the whole point.
They also optimized the tool use itself, right? To avoid that token inefficiency, where a model has to rethink every single step.
Yes, the thinking context management. It's a brilliant practical win. Old models would just discard the whole reasoning trace every time a new piece of info came in.
Forcing it to start from scratch. What a waste of tokens.
A huge waste. DeepSeek-V3.2 retains the historical reasoning content through a whole task. The trace only gets discarded when a brand new user message comes in. It cuts down on waste and maintains continuity.
Okay, so we have efficiency, stability, and generalization. Let's get to the payoff. How did DeepSeek V3.2 do on the big industry benchmarks?
Well, the official production version achieves similar performance to what we call GPT-5 High on core reasoning tasks. Still trailed Gemini 3.0 Pro a little bit.
But against other open source models.
It was a decisive win, especially on agentic tasks.
Tell us about the coding results. That's a big one for open source.
It is now. It resolved 73.1% of issues on SWE verified, which is outstanding, and hit 46.4% on Terminal Bench 2.0. On general tool use benchmarks, it really closed the gap, hitting 80.3% pass at 1 on the 2-bench average.
Now let's get back to that experimental model, the DeepSeek V3.2 Special. This was their moonshot, right? No constraints, just pure reasoning data.
Special really became a world champion reasoner. It set new milestones, gold medal level performance in the IMO with 35 out of 42 points.
Gold in the IOI as well.
Yep, 492 out of 600 points. And it solved 10 out of 12 problems in the ICPC World Finals. It even edged out Gemini 3.0 Pro on a tough math competition, the HMMT.
That one data point is just so important. It proves that an open model with enough targeted compute can match the absolute frontier in a specialized domain.
It does, but there's a serious trade-off here, a vulnerability they themselves are very open about.
And that brings us back to this idea of intelligence density.
Exactly. Specially requires significantly more output tokens to get that top-tier performance. For example, to hit a high code forces rating, it needed 77,000 output tokens to generate the code.
Compared to Gemini 3.0 Pro,
which needed just 22,000 tokens for a similar rating.
That's nearly a 4-fold increase in cost and latency just to get the answer out.
It is. So while brute force compute can buy you performance parity, which is a huge proof of concept, that intelligence density is still a massive proprietary advantage.
So to sum up this massive win for open source AI, DeepSeek V3.2 delivered on 3 fronts.
Architectural innovation with DSA/inference costs.
Massive and stabilized RL investment scale performance to new heights.
And intelligent synthetic data generation created genuinely generalizable agents.
The recipe for challenging the frontier is now essentially public.
It is. They proved that a huge investment in post-train compute can achieve functional parity with the best proprietary models in reasoning. The question is no longer if open models can compete, but how they compete economically.
And that leads to our final provocative thought for you, the listener. The path to closing the raw performance gap for open models is now clear. More compute, more innovation. But the next frontier isn't just about raw reasoning. It's about intelligence density, doing more with less. So if you had to choose between a model that is the very best reasoner but costs 4 times as much to run versus a model that is almost as good but dramatically cheaper, which one is the true winner in the race for scalable, widespread AI adoption? What cost premium are we really willing to pay for perfection? That's the choice the next generation of LLMs is going to force us all to make.